Hello guys, hope you're doing fine. Today we are going to start our first lesson in the fourth quarter, which is called trigonometric ratios. It will be a part 1 and prepared by me, Miss Salma Ahmed. What is a trigonometric ratios? It is a relation between angles and sides for a right triangles. So must be a right triangles, not any other type of triangles. So here we have a right triangles, two legs and the hypotenuse, which is the longest side in the triangle. We are going to start by this lesson, which is 18.2, sine and cosine ratios. Our objective by the end of this lesson, understand that by similarity, side ratios in right triangles are properties of an angle of the angles in the triangle, leading to definitions of trigonometric ratios for acute angles. And how can we use sine and cosine ratios and their inverses in calculations involving right triangles? Trigonometric ratios are for the right triangles, as we said before. So the first trigonometric ratio that we are going to study is sine theta equals opposite over hypotenuse. What is theta? Theta is the angle here, and I need to get a sine for this angle. So it will be opposite. So this is the side opposite or in front of the theta. And the hypotenuse is the longest side in the right triangle. So here is theta, and this is the opposite side. So it will be opposite over hypotenuse. If I need to get cosine theta, cosine for this angle, so now I'm going to take the adjacent one, which is the side beside the angle here. So it will be adjacent over hypotenuse. And the third trigonometric ratio, which is tan theta, and it is the opposite over the adjacent. So it will be the opposite over the adjacent, opposite side over the adjacent side or the nearby side. First, we are going to find the sine and cosine for an angle. Example 1. Write sine and cosine for each angle as a fraction and as a decimal rounded to the nearest thousandth. So here we have the triangle or the right triangle. So I need to find the sine and the cosine for D and sine and cosine for F. So these are the two acute angles that I'm going to get the trigonometric ratios for it. So for angle D, sine D, it will be the opposite side in front of the D. Here is D, and this is the front or the opposite one, which is EF. So it will be EF over the hypotenuse, which is DF. So it will be 8 over 17, and by approximation 0.471. We are going to get cosine D, which is the adjacent over hypotenuse. So the adjacent for D is the side beside it. So it will be DE over the hypotenuse, which is DF. So DE over DF, which is 15 over 17, and gives me 0.882. The same, we're going to find sine and cosine for angle F. So sine F, here we change the position of the angle, and I'm talking about a different angle. So the opposite for it will be the in front of it, which is DE. So it will be DE over DF, the hypotenuse. It will be 15 over 17, and it's giving me 0.882. Top cosine F, it will be the adjacent side for the angle F, which is EF over DF. So adjacent over hypotenuse equal EF over DF, which is 8 over 17, and gives me 0.471. Here we have or conclude that the sine of angle D is equal cosine F, and cosine D is equal cosine F. So here we have these two angles, which are a complementary angles, or they are completing each others. So here we have this angle sine D is equal cosine F, and cosine D is equal sine F. Second, using complementary angles. So we are going to illustrate this step here. If I have any triangle in my life, the sum of these three angles is equal 180. So if I have a right triangle here, so this is called a 90 degrees. So these two angles, the sum of them is a complementary or 90 degrees. So if this is theta, so angle B, it will be 90 minus theta. So as we said before, if angle A and angle B are acute angles in the right triangle, then sine A is equal cosine B, and sine A and cosine A equal sine B, as we mentioned before in the previous slide. So theta here is the measure of an acute angle, then sine theta is equal the cosine of the complementary angle, which is 90 minus theta. And cosine theta is equal to the sine of the complementary angle, which is 90 minus theta. Okay, let's take an example to illustrate this. Write each trigonometric expression. Given sine 38 degrees equals or approximately 0.616, write the sine of a complementary angle in terms of a sine of 38. Then find the cosine of the complementary angle. So here we have, if I have sine theta equal cosine 90 minus theta, which is the complementary, so theta here is 38. So I'm going to replace theta by 38. Sine 38 equal cosine 90 minus 38. So sine 38 degrees equal cosine 52. As I have sine 38, which is 0.616, so I'm going to replace this with that number, which is 0.616. Equals or approximately cosine 52. So how can we get 52, which is in a sine 38 is equal to the cosine of the complementary angle, which is 90 minus 38. It gives me 52. So the sine of the complementary angle is equal 0.616. Let's take another one. Cosine 60 equals 0.5. Write the sine. So I need to find, if it is a cosine, I need to find it in term of sine. Here we are, cosine theta is equal to the sine of the complementary angle, 90 minus theta. So here is theta, which is 60. So I'm going to replace it, cosine 60 equals sine 90 minus 60. So cosine 60 equals sine 30. As I have cosine 60, which is equal 0.5, so I'm going to replace this side by 0.5 equals sine 30, which is the complementary angle. Here is the complementary angle. So cosine is 60 is equal to the sine of the complementary angle. So the sine of the complementary angle is equal 0.5. Your turn, page 944 in your paper. Write each trigonometric expression, and it will be a more examples for the same idea. If I have cosine 73 approximately equals 0.292, write in form of sine, or write the sine of a complementary angle. So theta, it will be a 73, so 90 minus 73 equals 17. So sine is 17, which is sine of complementary angle, is equal to the same, which is the cosine, which is 0.292. Sine 45 is approximately 0.707. Write the cosine. So here we have the theta, which is 45. So 90 minus theta equals 45. So I'm going to get the cosine for the complementary. So this is sine 45 is equal to cosine el complementary angle, which is 90 minus 45, give me 45. It gives me 0.707, which is the same answer. Third, find side length using sine and cosine. So here we have unknown lengths, and we need to find it by using sine and cosine. You can use sine and cosine to solve real-world situations, like example 3 in page 944. A 12 feet ramp is installed alongside some steps to provide wheelchair access to a library. The ramp makes an angle 11 degree with the ground. Find each dimension to the nearest tenth of a foot. So I need to get the other two sides, the unknown two sides. Here he gives me the ramp, which is a 12 feet long, and he gave me an angle of the ramp, which is 11 degrees with the ground. So I need to find how long of this wall and how long the ramp is going to stand far from the wall. So I need to get x and y. So find the height x of the wall first. So what's the relation of x for the angle A that I have or the given? Yes, it is in front of it. So I'm going to use sine A is opposite over hypotenuse, which is the opposite is BC over the hypotenuse, which is AC. So it will be sine 11, which is A is 11, equal BC is x over the hypotenuse, which is 12. So I need to get x. So I'm going to get this 12 from the denominator to get it by times in the other side. So it will be 12 sine 11 degrees equals x. By using your calculator, you can find that x approximately 2.3 to the nearest tenth, as he said. Type. Now I'm going to get y. So what's the relation of this side to the angle that I have? Exactly, it is beside it. So I'm going to use, so I'm going to get y by using the cosine ratio or the trigonometric ratio, which is cosine, because it is beside the angle. So adjacent over hypotenuse, which is AB over the hypotenuse, which is AC. So AB, it will be y. So cosine 11, cosine A, which is 11, equals y over 12. I need to get y, so I'm going to get 12 up beside the cosine. It will be 12 cosine 11 equal, equals y. By using your calculator, you will find that y is equals approximately 11.8 to the nearest tenth. Let's have another example about the same idea. Page 945. Suppose a new regulation states that the maximum angle of a ramp for a wheelchair is 8. So here is the angle, which is 8 degrees. At least how long must the new ramp be? I need to know how long it will be, the ramp round to the nearest tenth of the foot. So I need to get Z. Sine A, this is the hypotenuse, by the way, for this triangle. So I have this angle, and it's given the wall, which is 2.3 feet, which is the opposite to A. So I need to use sine, not cosine, because this is the opposite side for the angle A. So it will be sine A equal BC over AC, BC over the AC, which is the hypotenuse. So sine 8 is approximately 2.3 over Z, which is the opposite over the hypotenuse. So let's calculate the Z. If I need Z, so I'm going to get it there in this side and get sine 8 to be down. So we are going to get Z up and get the sine 8 down in the denominator. So it will be 2.3 divided sine sine 8. So by using your calculator, it will be a very easy one. So Z is approximately 16.5. Fourth idea, finding angle measures using sine and cosine. To find an angle, we will use inverse trigonometric ratio. What's inverse trigonometric ratio? It will be if sine A equal x, yani if sine this angle is equal an answer, then sine -1 x equal the measures of the angle. So if I need angle here A alone, I have to move this sign to be on the other side by a power which is -1. Sine -1, it's called an inverse trigonometric ratio. It is the opposite sign, which is called sine -1, or the opposite for the function sine in your calculator. Read it inverse sine of x. We can read it inverse sine for x. The same for cosine A, which is x. So I need to get A. I have to move this cosine to the other side. When I'm moving the cosine to the other side, it will be a cosine -1. It's not times, by the way, yani cosine, it's not cosine times A. It is cosine angle A. So if I'm moving this sine or cosine from this side, I have to move them to be an inverse by power -1. And you will find it inside your calculators, by the way, and it's called inverse cosine of x. You can use a calculator to evaluate inverse trigonometric expressions. As here, to find measure of angle A, if I need to find this angle, and I have these two sides, one is a leg and one is a hypotenuse. So I need to get this angle, so it will be sine, sine A is equal opposite over hypotenuse. So it is 5/10, which is equals 1/2. So if I need measure of angle A, I need to find, or I need to translate, or I need to move the sign to the other side by a -1, which is the inverse sign. So sine -1, 1/2. By using your calculator, you will find it's equal to 30, because we are going to approximate it to the nearest degree. So measure of angle A is equal 30. Another example, page 946. Find the acute angle measures in this triangle to the nearest degree. So here I have two sides. One is a leg and one is a hypotenuse. And this is 90, well known. So I need to find the measure of angle R and the measure of angle P. Okay, so we need to find measure of angle R and P, those acute angles. Start to get measure of angle R. If you need to find the P, fine with me, yani. You're going to start by any one. So I'm going to get the R by sine R. I'm going to use this trigonometric ratio. Why? Because the R, it's the relation, what's R is having the opposite side, which is known, and the hypotenuse. So it is opposite over hypotenuse. So I'm going to use sine R equals opposite over hypotenuse, which is 7/13. So measure of angle R, I'm not going to change this as a decimal now. I have measure of angle R. I will move the sign to the other side by an inverse sign, which is sine -1, 7/13. Use your calculator in this step, and you will find it 32.5. And I need this angle to be to the nearest degree, so I am going to look for this 5 after the decimal. It will push the 2 before the decimal or not. Yes, it will push it because it is strong, so it will be approximately 33 degrees. So we need the angles to the nearest degree. It means that we don't need any decimal in the angles. So measure of angle R is equal 33 degrees. Now I'm going to get measure of angle P. So what's the relation between P and the known length of the sides? Yes, P I know the one beside it, which is 7. So I'm going to use the cosine this time. So I have here actually two methods to find measure of angle P. The first one, either to use the complementary angles or use the trigonometric ratio, which is the cosine. If I'm going to use the complementary angle, so measure of angle P is equal 90 minus measure of angle R, because P and R are a complementary angles, so it will be 90 minus measure of angle R, and here I have measure of angle R that I get it in the previous step. So it will be 90 minus 33, it gives me 57. Type. If I need to get it by a trigonometric ratio, so I'm going to see that the angle, I have the relation between the side beside it, so I'm going to move to get by cosine P equal adjacent over hypotenuse. So it will be 7 over 13. So if I need measure of angle P only, I have to move this cosine to the other side to be an inverse. So cosine negative 1/7 over 13. By using your calculator, you'll find it 57.4 to the nearest degree. So the 4, it will not push the 7 because it's weak. So it will stay as it is, 57 degrees. Here we are, we have the two answers are the same. So you can get it either by complementary angles way or by trigonometric ratio way. Your turn, page 946. If I have this triangle, I need to get the angles or the acute angles that I have. So I need to get Z and I need to get Y. So here are the two angles that I'm going to find to the nearest degree. Answer. If I'm going to get measure of angle Y, what's the relation of the sides that he's giving to me? This is the hypotenuse. Yes, exactly. What's the relation between the 14 and the Y? It's the adjacent. So here I'm going to use the cosine Y equal 14 over 23, which is adjacent over hypotenuse. So if I need measure of angle Y only, I'm going to move the cosine to be an inverse on the other side. It will be cosine negative 1 is 14 over 23. Using your calculator and write these all, it will be approximately 53 degree to the nearest degree. The same, I'm going to use measure of angle Z. Here, I'm going to use the method of a complementary angle, not a trigonometric function. Feel free if you need to find it by a trigonometric ratios. Then you can find angle Z by opposite over hypotenuse. So it will be the sine Z 14 over 23. Now I'm going to get it with the other one, which is a complementary, 90 minus measure of angle Y. Here is angle Y, which is 53. So I'm going to make 90 minus 53 and gives me 37 degrees. And that's it. It's very easy one and shortest. Thanks for watching and waiting for your questions. If you need anything, just please let me know. Thank you very much.